at this as an entire system, from the entire system point of view, we would say that the change in the energy of the system, that is this person who's not only jumping up but flailing around and increasing in temperature, is equal to the work done by all external forces, and the work done on this system as we move from this position to that position is only the work done by gravity, right? Because gravity is the only force that's acting over a change in distance, and gravity is doing negative work on the system because we're going up and gravity is pointing the other direction, so the work done by gravity is equal to minus mgh. Now, what is that change in energy in the system equal to? Well, let's see. The change in energy in the system has many forms. That's equal to the change in the translational kinetic energy. It's equal to the change in the thermal energy. It's equal to plus the change in thermal energy plus the change in chemical energy. You name it. All these other things go into this change in energy of the system. Notice I don't have any gravitational potential energy in the system because my system is merely the person. Gravity comes into play through this external work. Okay. So all of those, and I can have also a change in kinetic energy due to other stuff. By other stuff, I mean someone swinging their arms and unbending their knees. And so all of these have to add up to minus mgh. Well, I know what this term is because I just calculated it, and the change in the kinetic energy of the system is the change in the translational kinetic energy we just calculated to be F of the ground minus mg times h plus, and I'll just call this delta E rest, is equal to minus mgh. Alright, so what if you do the rearrangements? I think you find out that the I'm going to have to rearrange this for a moment, and let me just put my final result up here. Notice that this mgh is going to calculate out, cancel out that mgh over there, and so what I find is that the term, the force of the ground times the height that we raise the center of mass is equal to, the force of the ground is equal to the change in the energy of the rest of the system. So this is the part, this part here goes into all of the motion, the change in the thermal energy, all the things that we normally can't account for. Okay? So the bottom line is, if you want to figure out the change in the kinetic energy of an object, an extended object, then you use the point particle idea. You just reduce the object to its center of mass, and you consider the forces and the distances that the center of mass moves to calculate the change in translational kinetic energy. If you want to look at all of the other contributions, then you have to go back through this, but by knowing the change in the kinetic energy due to translation, you can separate out these other parts. Okay?